Assalamu alaikum. Today we are discussing about circuits and electronics. Their textbooks are mentioned in your screen, and there are some reference books. You can also follow it. There are some list of topics and chapters. We will start our first lecture. The first one is basic concepts and fundamental laws. Second one is basic resistive circuits. Third one is diodes and their applications. Next one is bipolar junction transistor BJTs. Then detailed systems and Boolean algebra. Next one is a combinational circuit, and at last sequential circuit. In this example, you see that the use of electronics in different fields of like electrical, electronics, like in power generation, transmission, distribution, at every aspects of life. In this example, this is an example of electronic circuits in which we see that like physical configuration in circuit diagram. You see that there's a 12-volt battery, and we can control by using a switch, and there are some connecting wires, and there are some resistive elements like any output device in this configuration. In the first example of like cars, you see that internal circuits of like headlights and batteries and the connection. Like if we want to switch on our headlights, so by using a switch button, and when we switch on the button, then its path will be complete, and after completing this path, our battery provides some energy in the form of voltages, so our headlight will be on. In electrical circuit, you see that there are simple basic circuit in which left side there is a voltage source, and then some resistive components and inductive components like inductor and like a capacitor, and someone is use conductor. Conducting wire used for the purpose of connectivity of a circuit. There are some electrical circuit in which we see that voltage source, resistive components, different electronic components like resistor, capacitor. This one is a capacitor, this one is inductor, and this one is resistors. So what is electric circuit? Electric circuit is an interconnection of electrical elements which are connected in a closed path by a conductor. You see it in a previous example. There are some closed path electrical component, different electrical components connecting by using of wires. These are wires, and these components are connecting with each other like in series combination, parallel combination, in closed loop form. So this highlighted point, this is node, this is reference node. So in next lectures we will discuss what's nodes, and how we can solve by using node analysis. These are next topic. So electrical circuit is an electrical circuit is an interconnections of electrical elements connected in a closed path by conductors. So there are some SI units like length. First one is length. Length is its basic unit is meter, and its unit symbol is m. Mass in kilogram, its symbolic unit is kilogram. Kg. Time in second is basic unit, and its symbol is s, small s. Electrical current, important thing, its basic unit is ampere. There are some subunits like milliampere, kiloampere, microampere, nanoampere, and its identification by using A. Temperature in Kelvin, and symbol is K. Luminous intensity candela, and its symbol is CD. There are some SI multipliers, SI unit multiplier like 10 is power 12 mentioned that in tera, its symbol is T. 10 is power 9. These are the units of in the form of positive, like 10 is power 9 is giga, and its mention is by using G. Next one is kilo. kilo in by k, and 10 raised power 3. So 10 raised power minus 3 is milli, mentioned by using m. 10 raised power minus 6 is micro, then minus 9 is nano, and minus 12 is pico. Revision of this lecture is: first one is charge, then we will discuss about current and voltages, then power and energy, then Ohm laws, then conductance, and then resistance. The first week of lectures is start up as basic concepts and their fundamental laws. So first one is charge. The definition of charge is that the electrical properties of the atomic particles of which matter consists. Charge is measured in coulomb. So its unit is coulomb. The charge on an electron, its quantity is minus 1.602 into 10 is power 19 coulomb. Minus sign indicates that the charge on electron is negative. So if we want to calculate 1 coulomb of charge, which is equal to 6.24 into 10 is power 18 electron, which means that 10 is power 18 electrons when will flow, it's contain a 1 coulomb of charge. So electricity, as we know that electricity in the form of current like amperes. So there are two types of electricity, like static electricity and current electricity. So static means that or charge, electric charge like electron is in static position, and from current electricity it's mean that electron will flow from one point to another point, like from higher potential to lower potential. It will in the form of current. So first we will discuss static electricity. So stationary charges like electric charge built up on an insulating material. When an insulating material it's some contain charge, like these are in rest form, like in insulating materials, their outermost orbit contains 8 electron, like valence orbit. It means its outer orbit is complete, and there is no need of escape or addition of electron. So it's mean that electron is in at rest position. So static means that electron is in rest. Electricity that exists until the two groups of opposite charges can find a path between each other to balance the system out. It's mean that if we energize an insulator or in the form of electrical engineering, we say that if we energize an electron, so it will escape from their position, which will in the form of electricity. Current electricity. This form of electricity exists when charges are able to constantly flow. Like we know that flow of electron is named as current, like electric current. So in current electricity, the main thing is that electron will be flow from one point to another point. In the form of technical words, we say that electron will be flow from higher potential to lower potential. It will create in the form of current, which is electric current. So current electricity is like dynamic. It's mean that charges are always on the movement, in the moving position. So in current electricity, the main study is that the flow of electron. So in electrical engineering or in electronics engineering, the basic study is the flow of electron. Flow of electron in electrical engineering, the study of electron from high power devices like transformer, generator, motors, and many more. So in electronic engineering, the study of electron from lower power devices like transistor, diode, triode, Zener diode, thyristor. So these are low power devices whose power rating voltage rating is between uh, 3 to 5 volts to 40 to 60 volts. So the main difference between conventional current is the flow of electron. In no way. That means that in real world we will study conventional current. Conventional current is electron flow of electron in a normal routine direction. So conventional current flow is the standard that most of all the world follows. So in books and other calculation, you see that we will use conventional current. It's mean that flow of electron in like from positive to negative terminal of battery. So law of conservation of charges. Charges can neither be created nor destroyed. So it will be transformed from one form of energy to another form of energy. So electronic current. The flow of electron is termed like electronic current, like electron current. Electrons flow from the negative terminal to the positive terminal of battery. So there are some main definition: electric current, electronic currents in which electron will flow from negative terminal of battery to the positive terminal. So in conventional current, simply current, like we study the positive charges carrier which causes a current. So conventional current flow from positive terminal to the negative terminal of battery. Electrical current. So electrical current is the basic simple definition, as you know, that I is equal to Q by T, which explains that the rate of flow of electrical charges like electron through a conductor or through a circuit element which causes a current. So flow of electron, flow of charges in a unit time, as mentioned in next lines. You see you also make definition from this calculations, unit calculation, like its unit is amperes, basic SI units, which is equivalent to coulomb per second, like I is equal to Q by T. 1 ampere is equal to when 1 coulomb of charge will flow from any conductor or any any electrical component in a 1 second, which causes a 1 ampere of current. So we also explain there when we say that 1 microampere current will flow, it means that 1 coulomb of charge or 1 microcoulomb of charge will flow through a conductor, through any electrical component in a second. So it will known as 1 microampere. If you say that our current will flow 1 milliampere, it's mean that 1 milli charge will flow from any electrical components or any conductor in 1 second. Its unit is 1 milliampere. So you see in this diagram that direction of current. So in right side you see that I is equal to NQ by T. In derivative forms, I is equal to dQ by dt, which means that rate of change of charges in the change of times, it name as amperes. So if we want to calculate how much charges, so we can integrate it. When we integrate its limit from t naught to t, so we will get how much charges will flow through a conductor. In left side you see that a conductor having some circuit element, their cross section area, their reference direction. So this both equations tells us that if we want to calculate the current, so rate of change of charges in unit with respect to rate of times, so we will get current. If we want to calculate the charges, how much charge will flow through a conductor of unit area. So we integrate the current and then we will get a charge, amount of charge. So there's a basic example in which you see that some resistive components like some electrical components in generalized form A, B, C, D, and there's some directions are given I1, I2, I3. These are randomly directions only for your understanding purpose, so that how current will flow from like from A side. You see that I1 current will flow in from A side and then will flow through B, and then at point this node above C, current will distribute. Some current will flow in this side and some current will flow from this side. So from in this closed loop, I3 current flow, and this point again I3 and I2 will be add up, and this sum will equal to I1. So there are two types of currents. First one is direct current. When a current is constant with time, we say that we have direct current, like abbreviated as DC current. Alternating current, named as AC, whose value will be changing with respect to time. So a current that varies with time, like changes its direction periodically. Periodically means that with respect to time. It's called alternating current, also named as AC. So in this diagram you see that example of AC current and DC current. There is some equation, like generalized equation. You also understand only that AC current and DC current, their waveform. These are also waveform of AC currents, but there some syntax is changing, like these are triangular waveform, square waveform, but we also say that these are AC waveform because their direction and amplitude changes with respect to time. Reference direction, which means that reference point is a point from which our current will be flow, like positive. We can also take at positive point as a reference point, and also take negative as a reference point. Voltage potential difference. It's the voltage that associated with the circuit element is that energy transferred per unit of charge. So a unit charge, like flow from one point, like higher potential to lower potential, through any electrical components, either it is resistive, capacitive, anyone. So it's named as potential difference. In another simplified form, the energy required to move a unit charge from one end of the battery to the another end, it's also known as potential difference. So when potential difference will be created, then our charge will be flow, which causes a current. The unit of voltage are volts, mentioned as V, which is equal to joules per coulomb. So energy is transferred when charge flow through the any electrical components, like resistive component or any components. When energy, like from any potential, from higher potential to lower potential, charge will be flow, then these electrical components will consume some energy. So in this example you see that there is some notation, like if we want to calculate the voltage between VAB, so these are two things, VAB and VBA. So it's only indicated by changing the flow of direction of current, like electron. So what is power? Rate of energy transfer, like time rate of expending or absorbing energy. So what is power? Power is that rate of change of work with respect to time. We can also note it that P is equal to V into I. It is also a product sum of voltage and current. Passive components, like their configuration and how can we refer it. Plus sign means that power is absorbed by the element. Minus sign means that power is supplied by the element. Energy. Electrical energy is defined as electrical charge that will be work to flow of electron, to flow of charges from one point or one place to another place. The energy absorbed or supplied by an element from time t1 to time 2 anytime. We can also calculate by using W is equal to integrate this power between two direction, and we will get energy. Kilowatt hour. There is another unit of electrical supplies authorities uses kilowatt, that or electrical consumption bill, and also in kVh, kilowatt hours. So electrical energy supplied to the consumer in the units is kilowatt hour. So 1 kilowatt hour is the amount of energy that would be converted by a 1000 watts appliances when used for 1 hour. So 1 kilowatt hour is equal to 3.6 megajoule or 3,600 kilojoules. Power and energy, the relation mentioned in you see in a video, P is equal to V into I. Also we want to calculate W in the form of P, so we can integrate it. Law of conservation of energies. So energy can neither be created nor destroyed, only it will be transferred. So algebraic sum of power in a circuit in any instant of time must be 0. So in a closed loop path, the power supplied by a source is equal to the power consumed in the circuit. So total power supplied to the circuit must be balanced to the power absorbed. So the total power supplied to the circuit by a source it must be equal to the sum of the power absorbed in a whole circuit. So in equation form, total power is equal to the sum of power which is divided into the whole circuit. Either its power will be absorbed or it will be dissipate. So there is some question: is electric current is a vector quantity? So electric current should be considered as a vector quantity as it has both magnitude and direction, because the flow of electron which tells us the direction of electric current. So we can also calculate by using vector additions, either by using law of parallelograms, in which the resultant vectors which tells us about the direction of current. So when the electric current does not obey this law, so for this purpose, this reason is that current is a scalar quantity and not a vector quantity if it doesn't obey law of parallelograms. So scalar quantities are added, subtracted, multiplied or divided by the simple rules of algebra. But work, energy, electric flux, volume, refractive index, time, speed, electric potential, potential difference, viscosity, density, power, mass, distance, temperature, electric charges, these are which types of quantity, scalar or vector. It's your task to tell either these quantities are scalar or vector.